Hello, I made this little wireless current sensor thingy the other day, so I thought I'd make a video and show you what it's all about. And you can't really see in there very well, but there's a Arduino Pro Mini and an NRF24L01 radio module and a little voltage step down regulator inside there. And the idea with this is that you'll connect a battery to one side and then something else that you're powering, in my case a quadcopter, on the other side, and this will send wirelessly down to this side, and we'll be able to see the voltage of the battery and the current that's being drawn through the wires on the ground while we're flying. So as a bit of background as to why I was interested in doing something like this, I bought this battery a while ago. I got this quite a while ago now. I think I got it in December. Yeah, because it was Hobby King's end of year sale when a lot of things were really quite cheap. And this was crazy cheap. I think it was $13 maybe, or $15 or something. It was pretty good value anyway. So I got it and I thought, I'll fly my quadcopter with this. But I was a little bit concerned about how much current I would be drawing out of it, because you can see here it has a fairly low discharge rating, so 10C is much lower than what we're typically used to. We're usually, like my other batteries, a bit more like this. This is why doesn't it focus? Come on. It says 45 to 90C. So even though this battery is smaller in capacity, you're looking, well, just roughly 80, 90 amps at least current, constant current coming from this one. But because this is a higher capacity, we can get away with 50 amps here. So it's still not really that much. But as long as you are not doing anything too drastic, like lots of heavy throttle usage or stuff like that, if you're just puttering around, maybe doing some aerial video or something, you can probably get away with something like this. But I was a little bit concerned with how much current I would be drawing from this battery, and I didn't really want to fly it too much without knowing for sure that I was going to be within the rated current for this battery. So it's actually, I did about 3 flights with it so far, but it spent most of its life just powering my FPV ground station. So that's a bit of a shame, really, isn't it? So to make sure I could use this a bit more, I wanted to know for certain while it was flying what current it was being drawn from it. And recently I'm starting to put more cameras and gimbals and stuff on my quadcopter, so I really want to make sure I'm not going to ruin the battery. Anyway, so I took a few photos while I did this, and I'm not going to heat shrink it to show you, but we can just look at the photos. First let's look at the main part of this, which was this, what do they call it? Power module, current module without BEC. And my eyesight is usually pretty good, but for some reason when I was looking at this listing, I completely missed the word without here. And a few other people did too, judging by the comments. Actually, to be fair, when I look down here, they've done the thing that they do so often on Banggood. They've just slapped in some copy and pasted text here. And if you're looking through here, you would see something like switching regulator outputs 3 amps max. So that kind of leads you to believe that there's a BEC on board, doesn't it? And then it says here without BEC, which is the actual truth. Anyway, so this functions by having a resistor on here, which is a very low resistance, but it can handle a lot of current going through it. And basically we can measure the difference in voltage from one side to the other, and it's only going to be a small difference, but the voltage drop across that low resistance resistor is enough to let us get an idea of what current's flowing through it. And we can just multiply that voltage by a certain number to get a number in amps. So that's how that works. And I'll just go back to my picture again. So you can see on here we have a ground and then a plus 5 volts. So if the module had a beck on it, this would be producing plus 5 volts, and there would be a beck on here. So as you can see, there's not one there. Then we have V, and this produces, I checked this with the voltmeter, and it seems to give you exactly 1/10 of the voltage that is on the battery. So that's a very nice, easy way to measure the battery voltage. And the I is current, and that gives you a slightly less convenient value. And it's also a very, very small voltage too. So I found that the numbers that I'm getting showing on my screen they're not very precise, but it's good enough for a rough estimate. So this photo here, what I've done here is I've taken a linear regulator off one of these old busted ESCs that I had, and I've stuck it onto the place that was there. Turns out to be just the right arrangement for using these pins to place my own voltage regulator on there. It turns out that this wasn't really necessary because the Pro Mini can probably run directly off this battery voltage anyway, and I was going to have to add a small voltage regulator for the for the NRF24 module anyway, so I didn't really need to do this, but I guess it's just kind of handy to have. And then I just soldered these 4 wires on and put some heat shrink over that. And okay, so these are the other pieces that I put in there. This is the step down voltage regulator. So I set this to 3 volts, and this just powers the radio module because this is not supposed to have more than 3.6 volts absolute maximum, whereas this is going to be running on 5 volts. And then connected them all up like that, and so you can probably get an idea of what's going on there. But the ground and VCC here, so this is ground and 5 volts, so this is being powered from here. So this linear regulator is just coming out here and powering the Arduino, and then the other red and yellow are on analog 0 and analog 1, so they're going to be measuring some voltages. And those are the two there, the I and the V. And I just sort of folded that over and put some wires there. I'll cut those other wires short and heat shrinked it up, so that's what we have there. So I guess the only other thing really to look at, I guess we kind of need to look at this if anybody wants to copy what I've done here. Basically this is exactly the same thing plus a screen and without the power module thingy. But I'll show you a sketch in a minute, and in the sketch it tells you what pins you need to connect the RF24 module up to. And I haven't mentioned in the sketch where you connect these pins up to, but it should be pretty obvious because this is just a normal I2C connections. So SDA will go to analog 4 and SCL will go to analog 5, I think is the normal way to do it on a Arduino Uno. But you might have a different screen, so I guess you could do it however you feel like. So let's have a look at the sketches that are running on these. There's not much to it. Where are they? TX. Okay, so this is wireless current meter TX. And I'll scroll up the top. So these are the pins that I'm using, and 9 and 10 will relate to this 9 and 10 there. So you can actually change those two if you want to. And then we have a structure with 2 floating point variables in it, one for the voltage, one for the current. And the instance of that structure. And then in the setup, we just set up the radio to begin using it. And then we just loop through taking an analog read, and this is going to give us a value between 0 and 1023. So I'm dividing that by 1023, that'll give us a value between 0 and 1. And then what this represents is a value between 0 and 5 volts. So if I multiply that by 5, then I get the value in volts. And then, as I mentioned before, the voltage that you see on the on this pin here, well, it's not a pin, wire, whatever, is exactly 1/10 of the voltage that's on the battery. So that's the reason I have multiplied it by 10, and I adjusted it a little bit. It wasn't exactly 10, but it was pretty close to 10. And then that'll give me the actual battery voltage. For the current, it's not quite so easy because it's not a multiple of a nice number like 10. And in fact, I had to do a little bit of current measuring. Actually, you can get away without measuring the current if you want to do it this way. You can look at the voltage of your battery. So you need a voltmeter, of course, to check the voltage of your battery. Then check the resistance of some resistance that you know. In my case, I used these. Oops, where's my screen? I used these resistors here to do it. And you want to have resistors that are pretty beefy like that. These are actually a little bit too small, but I managed to make it work by just connecting them up only briefly, and they started to get warm quite quickly, so you wouldn't want to do that. You wouldn't want to have them connected up for too long. Whoops, where's the other one? There. Alright, so you can calculate this. Actually, you can just do volts over ohms is amps, I think. Is that right? Yeah. And then I just confirmed this with my ammeter. Well, you don't actually need to use an ammeter, but theoretically it should be 1.26 amps for this case. So when the current was 1.26 amps going through these resistors, the voltage on the I wire, that one there, was 0.086 volts. Like I said, it's a very, very small value there. So what that means is that we can take the voltage that we see and we read in through, in this case, analog pin analog 1, and we can multiply it by 14.65 to get the actual current. And after I did this, I sort of had to fiddle around with the numbers a little bit, just looking at the values on my multimeter and the values that I was seeing on the screen, and just to get them to match up a bit, I just did a little bit of trial and error, and that ended up with this couple of numbers here. So depending on whatever the little components that you're using, you may have to twiddle with these numbers a little bit, and even then it's not going to be very precise, but it should be enough to let you know how much, a rough ballpark figure of how much current you're using from your battery. Good enough to let you know whether you're going to ruin the battery or not, that's for sure. So just let's have a look at it working, because I'm talking way too much already. Oh, hold on. Okay, let's have a look at it. We have the other side. We've got to look at this too, don't we? All right, we'll come back to that in a minute. Let's have a break from looking at source code. So I'm going to connect up this battery there. So that's enough to have it running. And if I turn this on, we should see 12 volts, okay, and 0 amps, but it's not always 0. You can see it sort of twitching a little bit. It actually twitched much more than that yesterday when I was looking at it. It was sort of 0.2 amps or something, even though there was nothing connected. So like I say, don't try and expect this to be accurate. Now I want to poke these in here just briefly, but then you can't see what's happening on there. So I've got this, put this block here, and if we can get this all in shot. Okay, it's out of focus, of course, but down the bottom there you can see I'm gonna poke these resistors in here, and we'll see what happens to the current reading. Okay, so that's 1.1 amps roughly there. Just do that again. Alright, so about 1.1 amps. And the other thing I'm going to try here is I have a little piece of wire connected from the middle of the resistors. So now I'm going to plug these two leads into the battery so that we're only going to be using it one resistor, and we should get roughly twice the current. Okay, like this. Yeah, so there should be about 2.18 amps. Okay. Oh, yeah, that's nice and warm. Put that over there. So that's how you warm up a resistor. Anyway, so I think you get the idea, right? So we can see the current and the voltage. The nice thing about this is that you can just stick this onto anything that uses an XT60 connector. And I know you can do voltage and current readings in flight using an OSD, but that requires a whole lot more wiring, and it requires, you know, video transmitters and video receivers and goggles and screens and antennas all over the place. And this is like I say, it's much more convenient. You can just take this to the flying field and, you know, loan it to a friend, and he can stick it on his thing and see how much current his quad is drawing. Very easy to do. Oh yeah. So we have to look at the other side of this sketch. This is pretty simple as well. It only looks a little bit more complicated because we have to deal with the screen. So that's what this stuff is here. This is one of those SSD 1306 screens. So there's a whole lot of stuff there dealing with the screen, and then we just have a struct that has the same stuff as we have in the struct over there. And we set up our radio in a similar way, except we open a reading pipe and we start listening instead of opening a writing pipe. This again is just for the screen. And then we just loop. Where is the loop? Okay, so we try and receive something and then we update the screen. This is pretty simple really. I don't think I need to explain it, but just notice that it's updating the screen every 500 milliseconds. So every half a second it's going to try and draw something on the screen. And if it has not received anything for 1 second, it's going to say receive no good, NG. Otherwise it's going to say OK. So that's why at the moment it says NG. And it will keep displaying the last voltage reading that it had when it was receiving something. So I tried this evening, and it went out of range pretty quickly, but that's probably because I'm just using one of these little PCB antennas. So as I suspected, after about 50 meters or so, it came up just saying NG pretty quickly. But that's okay, I think, isn't it? I mean, once you've figured out what current draw your quad is pulling, then you're just going to take this off. You don't really need it to actually fly around permanently. So anyway, I'll put the source code and stuff for this on my website if anybody wants to give it a try. Okay, I thought I'd do a little demonstration of how easy it is to switch this thing over. It's on here at the moment on the S500, and I'll do a little check here and see how much current draw we get with this, and then I'll just switch it over to these ones and try that as well. I'm recording the audio on here because this stupid Runcam doesn't record audio properly. And down here we have the receiver receiving OK at the moment, 11.96 volts, and I'm recording that with my Nexus 7 because my phone unfortunately doesn't know how to focus at close range like that. The other unfortunate thing is that we're going to see this rolling shutter display here, so you won't be able to see the numbers properly all the time, but you should be able to get good enough idea of what numbers are showing up there. Anyway, let's fly this a little bit and see what we get. You can see it shuddering. You can see it shuddering a bit because I haven't tuned it for this payload, which is we have a. It's kind of noisy, isn't it? Let's put it over there. I have some 300-gram weights on the bottom to simulate the weight of the gimbal, but the gimbal that I tuned this for is not actually on there, so it's a bit shuddery. But it flies all right. So that should give us an idea of what the hover current is. And I know it's not going to do a full punch out very nicely, but I'll do the best punch out I can, and we'll see what the maximum current draw is when we're going straight up. And yes, that was full throttle. Alright, that's another little bit of full throttle. So, like I say, the numbers are not very accurate, but it should be enough. Should be enough to give us an idea of what the maximum likely current draw will be. Alright, let's switch this over. Who's next? Little quad can be next. Little quad's got dirt on his face. What a mess. Alright, put this on here. He's a messy eater. And change the normal type. Okay, so we're receiving, yes, 11.26 volts this time. Recording on here still? Yep. A little bit windy, but I'll just try and hover in one spot. Golly, come on. There we go. Okay, that should give you an idea of the current for hover. There's a flip just to show off, and let's do now full throttle punch out. Do one more just in case we didn't get a good look at the numbers from that silly Nexus 7 camera. Ready? Okay, that'll do. I'll have to look at those numbers later, I think. Alright, who's next? Car. And this time I should be able to look at the numbers myself while I'm doing it, because this is a little bit less tricky to control and look somewhere else at the same time. huge crashes if something goes wrong. So turn them on, don't we? Okay. Good to go. Now this time we have 7.6 volts because it's a 2S battery that was at storage charge. So that's what we expect to see. And I tried this just before, and as soon as I go over about 6 or 7 meters away, we lose the signal because it's quite close to the ground. So I'll just have to keep it very close. If we go at just a moderate crawl speed like that, we get around about 2 amps or so. Yeah. A little bit faster, I'll just go in circles, that's easy, isn't it? Almost heading to 3 amps now. And full speed, let's do a full speed run. It's somewhere around 3 or 4 amps. Yeah, 3.5 to 4 amps when we're full speed running. But I noticed that right at the beginning when you do the first when you hit the throttle right at the beginning, you get quite a large spike of current. I'll see if I can, what was it, 18? It's hard to see because it goes away so quickly, and you probably can't see it very well on there, unfortunately, so I'll just have to tell you what I'm seeing in here. Let's do it again. Oh, that was 20-ish. I think I saw 24 that time. So right at the beginning you could be looking at, say, 25 amps or something. So that's good to know, isn't it? Can't remember what rating that ESC was. I think it was only 10 amps actually. But as long as it's, 30 amps burst, I suppose it's alright. So, alright, well, that should be enough to show you how it can be quite handy to switch that thing over from one model to another quite quickly without having to hook up OSDs or anything else. So, yeah, I think that brings me to the end of what I wanted to show you. And I'll just drive around a little bit here, and in the meantime, thank you for watching. See you next time. Go, get that butterfly.